All right, so remember that we talked about the standard form of a parabola and how it gives us all of this information on features of a graph. So let's use what we learned about standard form in the previous video to analyze the graph f of x equals 3 times x plus 1 squared minus 3. So that's our new function. And if we want to, we can go ahead and graph that in our graphing calculator. I already have the drawing here on the paper notes, but if you want to reproduce it in your graphing calculator, under y equals 3 parentheses x plus 1 close parentheses squared, and then minus 3. And of course, you could use the trace function to identify different points. All right, so let's break apart this function. First, we have our a coefficient, which is 3. So a equals 3. A is positive, greater than 0. So I think of a smiley face. That means we have an upward facing parabola. Our vertex, remember that this comes from h and k. Opposite sign for our x, same sign for our y. So we have x plus 1 in parentheses. That's going to be a negative 1 in our vertex. We have minus 3, and we'll keep the same sign for our y value. So our vertex at negative 1, negative 3. On our calculator using the trace function, let's just verify this. X equals negative 1 gives me y equals negative 3. And we can see it here on our graph. That's our vertex, negative 1, negative 3. All right, our axis of symmetry is always going to be x equals whatever the x coordinate is from our vertex. So x equals, and in this case, x equals negative 1. And that's represented by this dashed line here. X equals negative 1 is our axis of symmetry, our vertical line, our axis of symmetry. All right, for our x-intercepts, we can see visually that we have negative 2, 0, and 0, 0 as our two x-intercepts. Suppose that we, had a weird viewing window or something on our calculator. We couldn't really identify visually where our x-intercepts are. So it is important to know how to find your x-intercepts algebraically. So to do that, remember that you can set f of x equal to 0. So in our case, we have 3 times x plus 1 squared minus 3 equals 0. So we're doing this to find our x-intercepts. Okay. We would add 3 to both sides. This gives me 3 times x plus 1 squared equals positive 3. Then I'm going to divide both sides by 3. This gives me x plus 1 in parentheses squared equals positive 1. And now I'm going to take the square root of both sides, remembering my square root property, that plus or minus. So this leaves me with x plus 1 equals plus or minus, and then square root of 1 is just 1. So x equals negative 1, subtracting 1 from both sides, plus or minus 1. Negative 1 plus 1 gives me 0. Negative 1 minus 1 gives me negative 2. And those are my two x values for my x-intercepts. Okay, for my y-intercept, visually I can see again that my y-intercept is 0, 0. But if I couldn't see that visually on my graph for some reason, the way that we can find our y-intercept is just by evaluating f of 0. So in our case, 3 times 0 plus 1 squared minus 3 gives me 3 times 1 squared, which is just 3 times 1 minus 3, and 3 minus 3 equals 0. So that's the y value in my y-intercept. The domain, remember that this will always be negative to positive infinity because we're dealing with a polynomial function when we're dealing with a quadratic function. And then remember that the range will always be related to negative 3. So negative 3 is going to definitely make an appearance in my range. In this case, because I have an upward facing parabola, negative 3 is going to be the minimum value in my range. So my range is going to start at a minimum of -3, square bracket, because I can equal -3, and then it can go up to positive infinity. There's no vertical boundary there. And I just also want to point out, again, with this axis of symmetry, x equals -1, if we know that we have the ordered pair -2, 0 to the left of our axis of symmetry, 1 unit to the left, then we know that we'll have a matching symmetry point 1 unit to the right at 0, 0. So we always have those matching points to the left and right of our axis of symmetry. That's what that guy tells us. All right, looking at number 2, f of x equals -x plus 3 squared plus 4. So direction of opening is determined by a. A equals -1. That's the coefficient that's out in front. This is less than 0. That's a negative value. So I think of a frowny face. So we have a downward facing parabola. It's opening downward. My vertex, I have x plus 3 squared in parentheses here. So that's going to be a -3, opposite sign for x, plus 4. Keep the sign as +4 for y. My axis of symmetry, take the x value from your vertex, x equals -3. And again, remember, an axis of symmetry cannot just be a constant. So if you write the axis of symmetry as -3, that's wrong. Make sure you give me an equation of a vertical line. So here, our axis of symmetry, we could draw a dashed vertical line at x equals -3. Our x-intercept, we can see visually that we have -5, 0 and -1, 0. But if we wanted to verify this using algebra, remember that we could set f of x equal to 0. So if I take -x plus 3 squared plus 4, set that equal to 0. And then maybe you subtract 4 from both sides. So you have -x plus 3 squared equals -4. And then remember, this is really a coefficient of -1. So if I divide both sides by -1, this gives me +x plus 3 squared equals +4. Taking the square root of both sides, plus or minus, I have x plus 3 equals plus or minus the square root of 4, which is 2. Subtracting 3 from both sides, x equals -3 plus or minus 2. So -3 plus 2 is -1. -3 minus 2 is -5. And there's our -5 and -1. For your y-intercept, we can see here that it's going to be located, it's the vertex, whoopsies. So our vertex was at -3, 4. Our y-intercept, it looks like it's going to be at 0, -5. But this is a good example. I'm not quite sure. I'm kind of guessing looking at the graph. So let's go ahead and evaluate this and see if I'm even correct. F of 0 will give me my y-intercept. So this would be -0 plus 3 squared plus 4. So this is negative, and then 3 squared would be 9. So -9 plus 4 does give me -5. Okay. For our domain, because we have a polynomial function, -infinity to +infinity. And for our range, the y value from our vertex will always make an appearance in our range. So remember, our vertex is -3, 4. 4 is that maximum function value. It's the highest value on our function. So that +4 y value is going to appear to the right of our range. And then on the left, we'll go from -infinity up to a maximum of y equals 4.